Welcome back. We already created our first Spark streaming application and learned the basic model of stream processing in Apache Spark. Creating stream processing applications in Apache Spark is a 3-step process. And these 3 steps will automatically run in an infinite loop where each iteration is known as a micro batch. In this video, we will dig a little deeper into this loop and try to understand some more concepts. So let's start. Let me come back to the example code. Here it is. So what did we do here? We are reading a stream into a data frame. Then we are processing it and creating another data frame. Finally, we are writing it to the console. Where is the loop? We are not coding any while loop or a for loop here. So how does it happen? Let me explain. Starting a query acts like a Spark action. I hope you already understand what happens when we trigger a data frame action. Similar things will happen here. Your Spark driver will take the code starting from the read stream until the write stream and submits it to the Spark SQL engine. The SQL engine will analyze the code, optimize it, and compiles it to generate an execution plan. All this happens at runtime. And the generated execution plan is similar to the data frame execution plan, which is made up of stages and tasks. Once you have an execution plan, Spark will start a background thread to execute it. Until this stage, you will not see any Spark streaming job. The background thread does not show up as a Spark job. I'll show you all this. Now, the background thread will trigger one Spark job to do the following. Read the data from the source and create an input streaming data frame. Process the input data frame as per the defined logic to finally generate the output data frame. Write the output data frame to the given sink. That's your first micro batch. It ends here. So you should see a Spark job completed. Now the background thread will again look for the new inputs from the given data source. If you do not have any new inputs yet, the background job will wait for data to arrive. As soon as you get some new inputs, the background thread will clean the input data frame and load it with the new data. And that will be your input data for the second micro batch. The input data from the previous batch is already processed, and hence the background thread will discard it and load your input data frame with the newly arrived data. Make sense? Now the background thread will trigger another Spark job to repeat the processing and writing operation. And this new job becomes your second micro batch. The background process will wait for the second micro batch to complete and trigger the third micro batch if you have some more data to process. So the loop is created and managed by the background process, and it goes on forever. Make sense? You can see some of these things happening on your Spark UI. Let me show you. I am starting my input data source socket. I haven't sent anything yet. Now let me start the application. Then we go to the Spark UI. You will see one job which gets triggered and completes also. And this would be your first micro batch. If you click the job, you will see 2 stages. These 2 stages are obvious. The first stage is before the group by, and the second stage is for transformation after the group by. The group by operation triggers a shuffle, and you can see the exchange here, right? Nothing else is happening. We are not seeing any new job because the background process is waiting for the new inputs. Let me send some text. Good, batch 1 is triggered and we can see the output here, right? Let's go and check the Spark UI. Do you see one job? This new job was your next micro batch. Send some more inputs and you will see another micro batch job. And this loop goes on forever. Great. So now you understand how this micro batch works, right? However, I have a simple question. We saw that the micro batch loop triggers as soon as we get some new data. The question is simple. How much data do we need to trigger the new micro batch? Will it trigger for each record? Or is it based on time? Do we have some control here? Yes, we have. The data stream writer allows you to define the trigger. As of Spark 3.0, we have 4 trigger configurations. The first option is no trigger configuration. This example does not define any trigger configuration. So we are using the default unspecified trigger. In this case, the new micro batch is triggered as soon as the current micro batch finishes. However, the micro batch will wait for the new input data. And we have seen this behavior, right? The second option is to set some time limits for each micro batch. For example, you can set the trigger interval to 5 minutes. In this case, the first trigger will start immediately. The second micro batch will begin when the first trigger is complete. However, if the first trigger finishes in less than 5 minutes, the second micro batch will wait for the remaining time and only trigger when 5 minutes are over from the start of the first micro batch. If the first micro batch takes more than 5 minutes to complete, then the second micro batch will start immediately as soon as the first one ends, because we already passed the trigger time. Make sense? The time-based trigger gives you an option to collect some input data and process it together, rather than processing each and every record individually. The third option is like a batch processing. The one-time trigger will create one and only one micro batch, and then the background process will stop. This option is useful in scenarios when you want to spin up a Spark cluster in the cloud, such as Amazon EMR. Process everything available since the last period, and then shut down the cluster. So, in this case, you will be scheduling your job using a third-party scheduler, and the stream processing job acts as a batch job. However, you can still take advantage of other features, such as restarting from the same point where you stopped and combining intermediate results. The last option is a new feature in Apache Spark to achieve millisecond latencies. The micro batch approach is good enough to create micro batches and run as quickly as a few seconds. However, when you want to get things in less than a second, the micro batch approach may not be suitable. Apache Spark is evolving with the continuous triggers to achieve millisecond latencies, but this feature is still marked as experimental. Great. So we also learned the trigger configuration. I'll show you the mechanics of applying these triggers as we progress with the course. That's all for this video. Let me quickly summarize what we learned. Spark Stream Processing query runs as micro batches. Each micro batch starts with a new input dataset and writes the outcome to the sink. The next batch again starts with a new dataset, and this all goes in a loop. All of this is internally managed by a background thread. You can also configure the micro batch trigger time by setting the trigger time interval. Great, that's all for this video. See you again. Keep learning and keep growing.